Kirchhoff law. So it's an important law. Already you know that Ohm's law. Okay, Ohm's law, you know that Ohm's law is only for applicable for the steady current. So steady current only we can apply the Ohm's law, but that unsteady current we are not able to apply the Ohm's law. So Kirchhoff law is used for applying that unsteady current. Okay, so Kirchhoff law has the two laws. One is the current law, another one is the voltage law. So current law, or that is called junction rule. That's all the current rule or junction rule. Second one is called voltage rule or loop rule. So Kirchhoff first rule, or that is called current rule or junction rule, or that is called law. Kirchhoff second rule, voltage rule or loop rule. Okay. So here first you are going to see that current rule or junction rule or Kirchhoff first law. Okay. So say that Kirchhoff law. You can take the two circuits, circuit A and circuit B. Okay. So that circuits are not flowing through a steady current. So this circuit is connected with the resistance, battery and the key. Resistance may be connected in series or in parallel. Okay. So here that resistance and battery, that is EMF and keys are connected here. So it's a closed circuit. To solve the bridge circuit, the German physicist Robert Kirchhoff put two rule. One is the Kirchhoff first law or rule, or Kirchhoff second law or loop rule. So here, that first you are going to see the junction rule, or that is called first law, or current rule. We can call it the current rule. Okay. So see that bridge circuit, you can take as a junction. You can take the two junction a circuit, the point where three or more circuits meets in a junction. So see that this is a junction. So junction means 1, 2, 3. 3 lines are connected here. That's why this is called junction. So this is also another junction. This is also junction. This is also junction. So a junction in a circuit is a point where 3 or more conductors meet. Junctions are called nodes, or that is a branch of points. That's called branch of points. Okay. So here first rule is depending on that junction rule, or it's called current rule. The loop is any closed path. So this is a closed circuit. It should be a closed circuit. So see, this is a closed circuit. So it's a closed path. So in this closed path, it has the 3 or more. So junctions are connected. Then we can apply the Kirchhoff first law or the first rule. So it says the algebraic sum of current flowing at any junction is 0. So algebraic sum of current flowing in any circuit in a junction is 0. அதாவது என்ன அர்த்தம்னா எத்தனை லைன்ஸ் வந்தாலும் சரி அதோட ஜங்ஷன் கரண்ட் இப்போ 3, 4, 5 எவ்வளோ ஜங்ஷன்ஸ் எவ்வளோ கரண்ட் வந்தாலும் சரி the junction current becomes 0. So it states that the algebraic sum of the current flowing into the junction is 0. So our summation of delta I is a current, delta I. Summation of means we are adding all the current. You are adding all the current means it will become 0. So that is called the Kirchhoff first law. So current meeting at any junction in a circuit is 0. See that the 5 connections are there, I1, I2, I3 and I4. See the direction. I1, I3 and I5 are moving towards the junction. But I2, I4 are moving away from the junction. The current which is flows towards the junction is taken as positive. The current which is flowing in a outward direction is taken as a negative. It's very important. Current which flow from that point O to outer direction, that is I2 and I4, that is taken as a negative. But remaining current are flowing towards the junction is taken as positive. Okay. So towards the junction is positive. The flow from away outside is negative. So sum of all the current I1 minus I2 because I2 is moving in a outward direction plus I3 minus I4 plus I5 equal to 0. Or we can take that negative 2 current in the opposite direction I1 plus I2 plus I5 equal to I2 plus I4. I1 plus I3 plus I5 equal to I2 plus I4. So current flowing towards the junction is taken as a positive away from the negative. So the total current becomes 0. So it's called Kirchhoff current law. So algebraic sum of potential dot any loop that is also taken as summation of delta V equal to 0. That means we are adding that all the potential of the cells, current. Total current எப்படி add பண்றோமோ அதே மாதிரி total potential நம்ம add பண்ணிக்குவோம். That is a Kirchhoff first rule. Second rule, we can take the closed surface. Closed surface means the closed loop. It's a battery resistance are connected in a closed loop. So closed loop, that law states that the product of current and resistance in each part of any closed circuit is equal to that EMF of the circuit or EMF of in the closed circuit. So circuit எடுத்துக்கிட்டோம் அப்படின்னா அந்த சர்க்யூட்ல இங்க பாருங்க the potential drop across any resistance is taken as a positive in move in the direction of opposite. So the EMF of the source taken as negative if move in the positive terminal to negative terminal. So positive to negative terminal போச்சுன்னா that is clockwise direction, that is taken as a positive. அப்போ current is flow from the positive to negative means we are taken as a positive. So the current is flowing in this side. So this is positive. Suppose current is flowing in the opposite direction. That means negative to positive. See here, this is flow from the negative to positive. Here, positive to negative. This one is flow from positive to negative. That current is flowing in a negative to positive. That is anti-clockwise direction. So this is anti-clockwise direction. And this arrow mark is flowing in the clockwise direction. This arrow mark in the anti-clockwise direction. That current flowing in a clockwise direction is taken as a positive. That current is flowing in a anti-clockwise direction is a negative. Okay, so like that you can do the calculation by using the Kirchhoff second rule, voltage rule, or this is called loop rule. Voltage rule means V equal to IR. You know the formula. V equal to IR. Ohm's law. According to Ohm's law, V equal to IR. Here that law states that the product of current and resistance. Current and resistance. Current means I. Resistance means R. So the product of current and resistance I into R, that is equal to the EMF of the battery which is contained in the circuit. So this is called Kirchhoff second rule. அப்போ ஒரு சர்க்யூட் எடுத்துக்கிட்டோம்னா அந்த சர்க்யூட் இருக்கக்கூடிய கரண்ட்டையும் ரெசிஸ்டன்ஸையும் மல்டிப்ளை பண்ணோம்னா that value is equal to that EMF of the circuit. So இங்க வந்து பாத்தீங்க அப்படின்னா R2 is a resistance, I1 is a current, R3 is a resistance, I1, I2 is a current. So multiply these two values, you can get that value is equal to the EMF of E2 because it is in the clockwise direction. Suppose you are taking anti-clockwise direction, so the current is flowing in anti-clockwise direction. The product of R1, I2, I1 plus I2 into R3, the product of current and resistance. Front add பண்ணுவோம். That value is equal to the sum of EMF of the circuit, that is E1. This value is equal to E1. அதான் Kirchhoffோட second law. So the product of current and resistance in each part of any closed circuit is equal to the EMF of the circuit. So this is called Kirchhoff voltage rule or voltage loop rule. Okay. So this is important for the measuring the current in a clockwise direction, anti-clockwise direction, and it is for unsteady current and the closed loop. So example, I told you now that is given here A, B, E, F, A equal to minus of I1, I2 because it is in the anti-clockwise direction. I1, R2, that is also in the anti-clockwise direction means we have to put negative. Clockwise means positive. So E1 is positive, E2 is a negative. Here that minus I1, I2 because it is in the anti-clockwise direction, minus I2, R1 also in the negative direction. So this is the difference between the junction rule and the loop rule. Okay. So next we are going to see the Wheatstone bridge. So Wheatstone bridge, it's an important question. see Wheatstone bridge. இது வந்து ஒரு இம்பார்ட்டன்ட் 5 மார்க் கொஸ்டின். ரெகுலரா எல்லாத்துலயும் கேட்டுட்டே இருப்பாங்க. இப்போ இதுல வந்து பாத்தீங்க அப்படின்னா we know that Kirchhoff first rule and second rule. First rule நமக்கு தெரியும், செகண்ட் ரூல் நமக்கு தெரியும். ஃபர்ஸ்ட் ரூல் செகண்ட் ரூல் ரெண்டை யூஸ் பண்ணி ஒரு அன்னோன் ரெசிஸ்டன்ஸை எப்படி கால்குலேட் பண்றது அப்படிங்கிறது தான் இப்போ நம்ம பார்க்க போறோம். ஓகே, ஸோ அன்னோன் ரெசிஸ்டன்ஸ் எப்படி கால்குலேட் பண்றது பை யூசிங் த Wheatstone bridge. Okay, so here the Wheatstone bridge. Wheatstone bridge used for to measure the unknown resistance. Unknown by using the known resistance. Known resistance யூஸ் பண்ணி unknown resistance கால்குலேட் பண்ணலாம். அதாவது நம்ம தெரிஞ்ச ரெசிஸ்டன்ஸ் வச்சுக்கிட்டு ஒரு தெரியாத எந்த ஒரு ஆப்ஜெக்ட் ஒரு கண்டக்டரோட ரெசிஸ்டன்ஸையும் கால்குலேட் பண்றது யூஸ் பண்றது தான் Wheatstone bridge. So see that now the four resistance P, Q, R, S are connected. P, Q, R and S is connected with the battery E. So the junction A and C, it's a closed path. See, A, B, C, D is a closed path that is connected to that battery. So two junction A and C connected with the battery. So the flow of current I, the total current is I, but current flowing through the resistance PQRS is I1, I2, I3 and I4 are the four currents flowing through the resistance PQRS, and Ig for the current flowing through the galvanometer. So galvanometer resistance is taken as G, capital G. So applying the Kirchhoff first law. Kirchhoff first law is applied to the junction B. So in junction B, see that I1, Ig and I3 are in the junction B. Here Ig and I3 is moving outward direction, but I1 is moving towards the junction. So I1 is positive, Ig, I3 is negative because the two currents are flowing away from the junction, that is junction B. So that's why we are taken as I1 minus Ig minus I3 equal to 0 from this junction. See that this is inward, these two junctions are outward. Okay, then next thing, you can take the another junction D. In that junction D, see that I2 plus Ig minus I4, because in the junction D, I2 and Ig is moving towards the junction D, but that I4 is leaving away from the junction, that is taken as a minus I4. So this is equation number 4 according to the Kirchhoff first rule. அப்ப current உள்ள வந்தா that is positive, we have to add the value. அதே கரண்ட் வெளியில போனா நெகட்டிவ்னு எடுத்துக்கும். இதுதான் கிர்ச்சாஃபோட ஃபர்ஸ்ட் ரூல் நம்ம சொன்னோம். ஸோ அதை அப்ளை பண்ணி I2 plus Ig minus I4 equal to 0. So the next thing, again we are going to use the Kirchhoff second rule, that is loop rule. Okay, we are going to consider the closed surface area, that is A, B, D, A. In that area, we have to multiply the current and resistance. I1P, I1 is the current, P is the resistance. Like that IgG, I2R, I2 is the current, R is the resistance. Like that we are adding the all the values because it is in the clockwise direction. So applying the Kirchhoff second rule for the next closed loop, AB, C, D, A for the another loop. So what we have A, B, C, D, A. Here product of current and resistance. I1P plus I3Q, because I1P, I3Q in a clockwise direction, but in a I4S, I2R are in the anti-clockwise direction. That's why we are taken as negative. So I4S minus I2R. So negative, that is equal to 0. So this is applying the Kirchhoff second law. So now you see that, so in this closed circuit, we are taking the two equations. In this equation, we consider that the galvanometer, which is connected in the center, suppose the galvanometer shows 0 means that point B and D are in the equal. Potential of the point B and D is equal. That means galvanometer shows the 0 deflection. When we taken as Ig equal to 0 in all this equation, what will happen? That Ig becomes 0 in first equation, second equation and third equation. So new equation I1 equal to I3, I2 equal to I4 because the Ig becomes 0. Then next equation, when Ig equal to 0 means you will get I1P equal to I2R. Then next equation becomes Then substituting the value of 5, 6, 7 in equation 4. So in this equation, what will happen? I1P plus I1Q minus I2S minus I2R equal to 0. Or the negative அந்த பக்கம் கொண்டு போயிட்டீங்க அப்படின்னா I1 equal to P plus Q, I2 R காமனா இருக்கிறத I2 வெளியே எடுத்துட்டோம். So R plus S. So dividing that equation 7 by 8. So ரெண்டையும் பண்ணா I1 cancel ஆயிரும், I2 cancel ஆயிரும். Remaining values are P plus Q by P, R plus S by R. So that is a next value when you divide the two equations. So next thing is we can take it as 1 plus Q by P, because P get cancel each other, then R cancel each other, 1 plus Q by P, 1 plus S by R. Now we can cancel that 1 on the other side. So you will get Q by P equal to S by R. Or you can reciprocal do that value, P by Q equal to R by S. So P by Q equal to R by S. That is the final equation. This is the condition for the bridge balance P, Q, R and known as the resistance S can be calculated. If you know the three values, we can calculate the other one unknown value. So if you know the value of P, Q, R, you can calculate the value of S. Suppose you are knowing the value of R, S, Q, you can calculate the value of P. So using the Wheatstone bridge, we can calculate the unknown resistance by using the known resistance. Okay. So this is very important. So next thing is meter bridge